help teams, win robots 3 days, build our plan, challenge ourselves, and then win FRC.
Basically, the idea here was we kind of just said, why are we here doing this? What are we hoping to get out of it? It's kind of a not strictly necessary to make this perfect, but it's good that we have this discussion.
Yeah.
We just finished up reading the rules, so we're going to start with the group discussion.
Okay, so how exactly do we score in Autumn?
8 feet?
Early morning.
That's a big number. So yeah, this is going to be a half-scale diagram of all the heights that we're going to be dealing with in the game. So both the robot heights as well as all the field element heights where we need to score to give us a sense of scale for the game.
You have to spin it
Like
at
2 or
least
3
3 times,
but not
no
more.
less, not more than 5.
Okay.
If you go more than 5, it resets.
We wrote down some expected point totals for what we think teams should hopefully be able to score.
Incredible.
In this game.
So what we're doing right now is, now that we've discussed like general scoring stuff and all that, we're going to go through and work on a list of priorities. We're going to do that by starting by listing everything that we can do. So what are some things that we can do in this game that we want to consider? Clearly driving is a thing.
Driving important. Very good.
Pass rules.
Inspection.
I mean,
Oh, inspection. Okay,
Be
yes.
allowed to
Yeah,
play
true
on the
enough.
field.
Yes.
There is a possibility that you could construct a robot that can only climb when it's lowered. The practicality of that and whether or not it's useful is a discussion that we'll have immediately following this.
yeah.
But right now, let's just get out all of the different possibilities.
So obviously scoring.
So beyond
shooting
hanging,
power cells.
what else is there? Well, first, I feel like we should cover what we absolutely have to do, then we'll start prioritizing the rest of the stuff. Probably so. Yep. So you're saying gathering power cells should be our next priority?
We've only been talking about power cell scoring, although I think it's really important to note how many points are associated with endgame.
Within that, within hanging itself, how are we going to prioritize those three?
Okay, so after hanging, what's our next highest priority?
Scoring power cells.
Scoring power cells.
Okay, so what we're going to be doing now is, now that we've got our priorities figured out, we're going to break into small groups of 4 or 5, and individually, as teams come up with some solutions to these goals that we have.
We winched ourselves.
Yeah.
Super consistent.
You had
I don't think it
idea.
works for this.
But the thing is, it's too slow.
So
No, this was fast.
Oh,
Which is gonna be really fast,
Because, like,
especially if we make a relatively light robot.
We just had like
You seem to be tending towards a gap in the bumper, right? I would probably just have that go over the bumper, but same roller.
Then we're going to come back together, compare what we came up with, and see how we can move forward with this.
For considering hanging was our first priority, right? We talked about
This is a 2D sketch to test to see if we can get into both the inner goal and the outer goal.
I mean, we can play this book.
Yeah, I guess the takeaway here is it's close, maybe possible, but to give us our best shot, we really need a long chassis.
So we finished in our small groups talking about what designs we came up with. We shared in a big group. We just talked about what we liked, what we didn't like. We decided on a couple of things to prototype on, and now we're going to split up into some more groups to prototype those things. And we also did some math.
this is a very poor mock-up of an elevator system in order to deliver a hook of some manner to a bar so that we can climb. So basically, you have your 2 pieces of metal. You have, in this case, a piece of twine. Hopefully, this is going to be not twine, like a cable, something a lot stronger than twine, right? And it is connected to the second bar. You pull it right, and it elevates. Isn't that fantastic? You'll note that there's a lot of twine in this. You don't want that in your final product. That's why this is a mock-up.
This is a prototype of the switch, which is what
teens are supposed to hang on at endgame. And so right now the maximum tilt it'll get is 15 degrees. So the prototype is of the metal bar at 15 degrees. And so this is like our simulation of a hanger hook, like hang on it. And so when it was just metal, like we didn't have anything on it, it was super slippery. And so we're figuring out ways to make it slip less or not slip at all. And so we tried putting duct tape over the metal and it slipped a little less. We tried putting electrical tape, it was still pretty slippery. Then we tried a pool noodle and it was a lot less slippery.
Go. We're doing a flywheel test. So we switched out down to 2 6-inch wheels and 2 of the 4-inch wheels. 4-inch wheels are mostly just to increase the weight of the flywheel so we can get that rotational inertia we were talking about. Spinning up drill. That's pretty good.
I think that now is the time that we need to discuss our strategy moving forward, make sure we're on the same page. First off, as far as prototypes go, was there anything that we learned that should majorly inform our design going forward? Intake suite. As far as climbing systems, do we have any information on that?
I think at some point we do have to consider the complexity of actually making an elevator versus the complexity of actually making a arm.
So right now we're just getting off about 2 hours of prototyping and strategy. So we've kind of come back together just now, had a meeting about said strategy, and we're going to go back out, start CADing, start putting a drivetrain together, start programming, get electrical on the way, and really just kind of starting to get into the meat of things here.
So basically how we got to this point in the CAD was we made skeleton sketches based on geometry that we knew we would need to make these mechanisms fit in the robot geometrically, and then fleshed out the frame around those skeleton sketches. So that's what we have here. There are points for attachment of bearings and shafts and things like that that we'll need for the robot to function properly.